of you. This is your Prabhakar and welcome to our channel Dawn of Chemistry. Hope all of you are happy and healthy in your homes. Stay home, stay safe. Yeah. So far I have been making videos on electrochemistry and then IUPAC nomenclature and all. In this video I am going to explain about the chemical kinetics. This chemical kinetics is very important for advanced examination. In 2020 advanced examinations, 2 questions came from this chemical kinetics, and in the mains examinations repeatedly every year you can find 1 question. If you see local CET examinations, the most difficult questions will be from chemical kinetics. But in this video, if you follow these videos, means it will not be that much difficult for you to solve the problems. Let us get into the details. Chemical kinetics. Right. In this video, I am going to explain about the introduction to the chemical kinetics. What is chemical kinetics? What is the scope of the chemical kinetics and how many types of chemical reactions are there? What is rate of reaction and how many types of rate of reactions are present? Let us discuss about those things, and if time permits means I will discuss about the rate expression also. Right. First let us see what is this chemical kinetics. If you take there is a chemical reaction, A plus B gives C plus D. Every chemical reaction can be studied by using thermodynamics, chemical kinetics, and equilibrium. These 3 are the 3 concepts which are very important to understand about any chemical reaction completely. If you look at the thermodynamics deals with delta H values and delta G values. Delta G is positive, means it is spontaneous. Delta G is positive, means it is non-spontaneous. Delta G is negative, means it is spontaneous. Only thermodynamics explains whether the reaction will happen or does not happen. That much only we can study by using the thermodynamics. And equilibrium explains about the extent of reaction. Extent of reaction. That means when there is a reaction, of course here I am giving forward direction, it will be reversible also. If it is for the reversible reaction, means that will go up to the 98% completion. If you take equilibrium reaction, means all reactions will not go to that much extent. So to extent or to how much extent the reaction will happen, how much percentage of reactants converts into products, and how much products are formed after a particular time and all can be studied by using equilibrium. But chemical kinetics, the name itself indicates the branch of chemistry. Chemical kinetics is the branch of chemistry which deals with speed of reaction and mechanism of reaction and effect of temperature, pressure, concentration and catalyst on rate of reaction is called chemical kinetics. So the branch of chemistry which deals with speed of reaction. If you take a particular chemical reaction, it is forming products in 10 minutes, or whether it is forming products in 20 minutes, whether it is forming products in 30 minutes, or 10 minutes, how much reaction happened, that kind of things can be studied by using the chemical kinetics, the branch of chemistry which deals with speed of reaction and mechanism of the reaction. Whenever there is a chemical reaction, always that will not happen in the single step. Very fast reactions and very slow reactions will happen like that. But normal reactions you take means they will not take They will not happen in single step. There will be so many steps will be present in between. So what are those steps means? We can understand them or we can study them in the chemical kinetics. And what is the effect of temperature, pressure, catalyst and concentration of the species on the rate of reaction? Those things are we can study under the chemical kinetics. Simple thing, we can explain this like this. There is a bike. You have petrol, diesel, water. So when petrol, diesel and water is present, with this you can start the bike. With petrol and diesel we can start the bike, with water we can't start the bike. That's what we study. Whether the bike will start or not can be studied under the thermodynamic concept. If bike is started, to how much distance it will go. When you are from point A to point B, so whether it completely goes to the point B or whether it will stop in between, that is studied by the equilibrium. Based on the quantity of the fuel we are taking, we can decide. In the same way, if you take a reaction, to how much extent the bike will go can be studied. At the same time, what will be the speed of the bike? If you take XL means, that will go with some speed. If you take Splendor means, it will go with some speed. If you take Pulsar means, it will go with some speed. If you take KTM means, it will go with some speed. What will be the speed of the bike? If you take Splendor, it will go with some speed. If you take Pulsar means, it will go with some speed. And if you take KTM means, it will go with some speed. So what will be the speed of the bike can be also studied. In the same way, whenever there is a chemical reaction, to what is the speed of the chemical reaction can be studied under the chemical kinetics. So what is chemical kinetics? How to study about a reaction? What is the significance of thermodynamics, chemical kinetics and equilibrium? Now let us see, sir, can we study all the chemical reactions by using this chemical kinetics? Means no, it's a no. We can't study the rate of all the chemical reactions by using chemical kinetics. Only a few reactions can be studied. Let us see what are those reactions and how can we study about them. Basically, based on the speed of chemical reaction, chemical reactions are classified into three categories. That is, very slow reactions, another one is very fast reactions, and moderate reactions. Basically, we can classify the types of reaction or chemical reactions into three types based on very slow reactions, very fast reactions and then moderate reactions. Very slow reactions means reactions which takes months and years of time to form the products are known as the very slow reactions. Very fast reactions means reactions which forms products within fraction of seconds, like 10 power minus 14 to 10 power minus 16 seconds to form the products. They are known as the very fast reactions. Finally, moderate reactions means which will be in between these two categories are known as the moderate reactions. Only we can study the speed of moderate reactions by using chemical kinetics. Very slow reactions cannot be studied, and very fast reactions also cannot be studied. So be careful with this thing. Let us see what are very slow reactions means. H2 plus O2 gives 2H2O, CO plus half O2 gives CO2, CO plus H2 gives CH3OH, rusting of iron. All these reactions are very slow reactions. And you see, very fast reactions are AgNO3 plus KCl gives AgCl plus KNO3 will come, HCl plus NaOH gives NaCl plus H2O will come. BaCl2 plus H2SO4 gives BaSO4 plus 2HCl will come. Like this, whatever the neutralization reactions are there and whatever the precipitation reactions are present, all those comes under the very fast reactions, and very slow reactions are water formation from hydrogen and oxygen, carbon dioxide formation from carbon monoxide and oxygen, and C plus O2 gives CO2, also very slow reaction. If you see this thing, CO and CO2 case, we can convert very slow reactions into very fast reactions by maintaining the temperature and then catalyst. If you can maintain 300 degrees centigrade temperature and zinc oxide and then chromium trioxide, if we can arrange here, means that will become a moderate reaction. Like this, very slow reactions can be made into the moderate reactions by changing the environmental conditions of the reaction. And let us see what are the moderate reactions mean. These are important reactions. About these only we are going to study. What are the moderate reactions means? N2 plus 3H2 gives 2NH3, PCl5 gives PCl3 plus Cl2, N2O4. N2O4 gives 2NO2, CH3COO, C2H5 plus H2O gives CH3COOH and then C2H5, OHCO plus Cl2 gives COCl2. Like this, so many reactions are there which comes under the category of moderate reactions. Like this, there are so many reactions which we will encounter in the further coming classes. Like this, we can study about the chemical kinetics. Here, whatever the reactions I am writing, all these reactions we are going to study in our future coming videos. So this is the thing regarding what is chemical kinetics, what are the basic terminologies in chemical kinetics, what are very slow reactions, very fast reactions and moderate reactions. Why I am stressing on this thing means, in exams they will ask you which of the following is a very fast reaction, which of the following is a slow reaction, which of the following are the moderate reactions. That kind of questions they will ask you. So you should be very careful about the things. So that is the thing regarding the introduction to the chemical kinetics. And after this thing, let us discuss about the rate of reaction. What is the rate of reaction? How many types of rate of reactions are present? I will look on these things. Hope you've gone through. Let us move into the things. Chemical kinetics. In this chemical kinetics, let us discuss about the rate of reaction. Rate of reaction. Basically, rate of reaction is nothing but velocity of reaction or speed of reaction. You know very well, whenever there is a car or motorbike or any lorry are there means, we will find velocity is equals to distance travelled by time, or change in displacement by change in time we will take. But in case of chemical reactions, they will not move from one place to another place. That's why we will find the change in concentration of a reactant or product with time. Let us take a chemical reaction. Reactants gives products, or you can consider a reaction A gives B. So what we will do means, for every interval of time we will find change in concentration of A or change in concentration of B, and we will take the ratio of the change in concentration of A versus change in time. Change in concentration of B versus change in time, that gives the rate of reaction. So rate of reaction is equals to change in concentration by change in time. So rate of reaction is equals to change in concentration by change in time will come. So R is equals to change in concentration means delta A by change in time, it will be delta T. So delta A by delta T. This indicates, here you see concentration of A. As the time is going on, concentration of A will be decreasing. So we will put minus delta A by delta T, and concentration of B will be increasing time to time. So we will put delta B by delta T. So whenever you take any chemical reaction, in that case concentration of A will be gradually decreasing and concentration of B will be gradually increasing. We will consider this as decrease in concentration of A with change in time, or increase in concentration of B with change in time we will be writing. That is nothing but the rate of reaction. So rate is always change with time. If you take this rate of reaction, there are two types of rate of reactions are there. There are two types of rate of reactions are there. That is average rate of reaction and instantaneous rate of reaction. So basically there are two types of rates are present. One is average rate of reaction and one is instantaneous rate of reaction. What is this average rate of reaction and then instantaneous rate of reaction, and how to identify them means, let us see. Average rate of reaction means total change in concentration divided by total change in time. So how can you define average rate of a reaction means total change in concentration by total change in time is called as the average rate of reaction. So rate average is equals to delta A by delta T, that is minus will come and delta B by delta T will be coming. Instantaneous rate of reaction means change in concentration by change in concentration divided by change in time at a particular time. Or you can take small change in concentration divided by small change in time at a particular time is known as a instantaneous rate of reaction. Or instantaneous is equals to dA by dt, that is equals to d of B by dt. What is the difference between d and delta means delta is a large change in will be explaining, and small d will be explaining the small change in the concentration. Let us see, for example, there is reaction A gives B. I will explain with the example, you can understand. When time equals to 0, concentration of A is equals to concentration of B. How we will do any reaction means, first we will take A in a reaction vessel and we will start reaction. Initially, what is the concentration of A, what is the concentration of B, we will find. After 10 minutes, we will find concentration of A and B. This will be 0.9 GB1. So after 10 minutes, we will find. You can be taking at different intervals. You can take at 10 minutes, you can take at 1 minute, you can take at 20 minutes, you can take at 30 minutes, but the regular time interval should be same only. So whenever you are taking or whenever you are calculating the rate for a particular reaction means, frequently at a different time intervals we will take out the reaction mixture, we will freeze the reaction mixture. Why we have to freeze the reaction mixture means, if you take the reaction mixture and find the concentration means during the doing experiment only the reaction will be happening. So to avoid that thing, we will take reaction mixture, we will keep it in a fridge or refrigerator for up to 0 degrees centigrade. So the reaction will stop. That time we will take reaction mixture and we will find concentration of A and B. When T equals to 20, T equals to 0.8 and this will be 0.2. T equals to 30, concentration of A will be 0.7 and 0.3. T equals to 40, 0.6 and 0.4. Like that at different time intervals, we can find the concentration of A and B. So now you see exactly after T equals to 100 minutes, this is 0.1, this is 0.9 is coming. So what is that meaning? Exactly at 100 minutes, exactly at 90 minutes, this is 0.1, this is 0.9. What is the average rate of reaction means? Total change in concentration 1 to 0.1. So R average is equals to 0.9 by 90 and R average this is with respect to A. With respect to B it will be change will be 0.9 by 90. So this is the rate average will come. But what about the instantaneous rate means? That is difficult. Is it clear, ma? So whenever they give you change in concentrations and change in time with different time intervals, we will find the average rate. Total change in concentration by total change in time will be coming. This kind of things are very, very important during the rate calculation. Directly average rate you can calculate by total change in concentration by total change in time. But this will be carrying negative charge and the other will be carrying the positive charge. If you see, how can we find the instantaneous rate of a reaction? This is important one, ma. Listen carefully. So directly we can find the total change in concentration by total change in time and we can identify the rate of reaction. Now let us see instantaneous rate. Rate of a reaction or change, small change in concentration with respect to small change in time at a particular time is known as the instantaneous rate. How can we find instantaneous rate means? We will plot a graph between concentration versus time. Whenever you plot a graph between concentration versus time, concentration of A will be decreasing. Here I will write concentration. So initially concentration of A is maximum. As the time is going on, concentration of A will be decreasing with time. What about the concentration of B means? It will be concentration of B will be gradually increasing. Here this is time 0, 10, 20, 30, 40, 60, 70, like that it continues. For example, if you want to find instantaneous rate at 40th minute, listen carefully. Whenever you want to find at any point instantaneous rate means at a particular time interval. If I want to find at 20 means I will draw an intercept or I will draw a tangent onto the concentration graph at the particular time interval. Exactly, if you want to find instantaneous rate at 20 minutes, I will draw an intercept onto the concentration graph related to the particular time interval, and at the intercept I will draw a tangent. At the intercept I will draw a tangent. The slope of tangent is average rate. The slope of tangent is average rate, that is change in concentration by change in time. So delta C. At this particular time you can have this and this values also. You know very well how to find the slope value. This is the change in concentration and this will be the change in time. Like this we can find the instantaneous rate of reaction. So be careful with this. Average rate can be directly calculated by finding the change in concentration with the change in time, but whenever it comes to the instantaneous rate, you have to find the instantaneous rate. Whatever the time interval they are asking you the instantaneous rate, we will draw a intercept onto the concentration graph. You can write onto concentration graph of A, you can write onto concentration graph of B. There is no problem at all. At that particular point, we will draw a tangent onto the particular intercept. The slope of the tangent gives you the instantaneous rate. In advanced and mains examination, this kind of questions, there is a very much frequency of asking the problem. Here you see it is going exponentially, right? Here you see the concentration is changing invariably, but why it is going exponential curve means time change exponentially. Time change exponentially, and hence the concentration also will be changing exponentially. Concentration change will be linear, but time change will be exponential, and hence the curve will be like this. For anything you take the curve means that will be of this kind only. That is the thing regarding what is average rate of reaction and what is instantaneous rate of reaction. If you see here now, what are the units of the rate of reaction? This is very, very important one. What are the units of the rate of reaction? Means the units is, you know very well, R equals to change in concentration by change in time. What will be the concentration units means? Mole, liter inverse, second inverse, or mole, liter inverse, minute inverse, mole, liter inverse, hour inverse, mole, liter inverse, day inverse, mole, liter inverse, month inverse. Like this we can study the, or we can write the units for the rate of reaction. Now this is very, very important point. How much time is taken for completion of a reaction? Sir, is it possible to go completion of 100% of any reaction? Means it is not possible. Remember this carefully. Whenever there is a reaction, A gives B. If the reaction completes by 98%, then we say the reaction went for completion. For any reaction, 100% completion is not possible for the reaction. Slowly, because as the time is going on, even for very fast reactions also, as the time is going on, the concentration of reactant will be gradually decreasing. So the rate of reaction gradually decreases, and hence it's not possible for any reaction to go for 100% completion. Then when we consider a reaction to be completed means if the concentration of A decreases by 98%, or if concentration of products increases by the 98%, then we will consider the reaction to be completed. 100% completion is not possible for any kind of reaction. So be careful with this point. Like this, we can study about the what is the rate of reaction and how to find the rate of reaction, what is the significance of negative sign in the rate of reaction, and how many types of rates are present, and how to identify the particular rates in the reaction. Like this, we can study about the rate of reaction. That is with this video. In the next video, I will be explaining about the rate expression, how to write the rate expression, how to do problems based on the rate expression, and then different rate things. After that, we will be discussing about the orders of the reaction, and then how to find the orders of the reaction, and then half-life periods and all. If you are new to this channel, then subscribe to the channel for more updates from this channel. Like the video and share the video. Thank you.